So we're going to start out week 8 by talking about something called the Wiggers diagram. Now the Wiggers diagram has been known to intimidate students, and I understand why, but we're going to try and break that down so it's a little more easily understood. And so in talking about the Wiggers diagram, we're going to go across these 5 or cover these 5 topics and outcomes. And just to let you know, we're actually going to break down the Wiggers diagram over 2 of these lectures. So to start off, we need to know what's a cardiac cycle. Okay, so the cardiac cycle is essentially what it sounds like. It's just one entire cycle of what the heart goes through. Okay, now oftentimes you'll see it with 5 cycles, but I like to think of it in terms of 4. And so what we do is we basically put these 2 together. Okay, and so the way that we look at this is as follows. Okay, basically what's going on with the volume, okay, and then what's going on with pressure. And we give names to both of these. So when we look at the Wiggers diagram, there's a lot going on. So we've got heart sounds, we've got volume, so volume, heart sounds, pressures, and the electrocardiogram. On the one that you'll do for your EB, or that I encourage you to try and go through with your EB, there's also just letting you know if the valves are open or closed. Now, like I said, there's 4 different phases here, but we're really going to divide the whole thing into 2 phases, and then each of those 2 phases in half. Okay, and so when it comes to the cardiac cycle, we've got systole, which is contraction, and diastole, which is relaxation. Okay, and really, these are your 4 phases. Okay, the heart is contracting, and then the heart is emptying. Now, to be clear, when the heart is emptying, it's also contracting. And then diastole, you've got relaxation, and then you've got filling. And again, during diastole, when the heart is filling, it is in a relaxed state. So one cardiac cycle goes from what we call R to R. Okay, and you'll talk about this in lecture or in lab. So there's R, and then there's R. So that's one cardiac cycle. And we use that because R is really easy to find on an EKG or an ECG. And so we break it up into systole and diastole. The heart's either contracting or it's relaxing. It's important to know that atrial systole occurs just before ventricular systole. Okay, and then atrial and ventricular diastole, they can overlap. But if everything's working correctly, the atria are contracting at a completely different time from the ventricles. Okay, and then at the end of diastole, we have systole. So let's talk about ventricular systole. Okay, we're going to focus on volume here. And so we're going to focus where E is at. Okay, so E we call end diastolic volume. Now remember, diastole, ventricular diastole ends here at this line. And this line is essentially flat. We're just going to draw it that way so it's flat. So volume is constant here. Okay, so for this phase, this first little phase, volume is constant. And then during the second half, and it's not really a half, but just during most of systole, volume's actually decreasing. Okay, then we've got F, which is end systolic volume. So how much blood's left in the heart at the end of contraction, right? So it's a flat line, and so we have this period where it's constant, and then we have a period during diastole where volume increases, and we'll get into each of those later. Now we're going to give a name to each of these phases of systole based on what's going on with volume. Okay, so the first one is what we call isovolumetric contraction, or isovolumetric, meaning constant volume. Okay, I want you to think about what's going on with the AV valves and the semilunar valves at the time. And then we have ejection. And again, what's going on with the valves? So during this first phase, volume's constant. During the second phase, volume's decreasing. And so if we look at the valves during isovolumic contraction, just think about a water balloon. If you're squeezing a water balloon, what can you do to prevent water from leaving? And the answer is to tie it off. And that's the same thing that's going on with your heart, is those valves are all closed. The AV valve's closed and the semilunar valves are closed. However, when blood is leaving the heart, leaving the ventricles specifically, the semilunar valves have to open. And so blood is able to leave the ventricle and go into the aorta. Now let's do the same thing for diastole. Okay, so we've got isovolumic relaxation. So this is that period of time where we have constant volume. And then we've got ventricular filling. So now we've got volume increasing And there's actually kind of 3 phases to that we'll get into in a minute. But with the valves, if it's isovolumic, then the valves are all closed. Okay, that's what allows it to be constant volume. Okay, during ventricular filling, we have to have valves open so that more blood can go into the ventricle. And since blood goes from the atria to the ventricles, we know that the AV valves have to be open. Okay, now I want to just expand on this ventricular filling phase for just a second. So there's actually 3 phases. And so you've got this rapid filling that goes from here to about, I don't know, here. Okay, it's not like you'll ever necessarily have to specifically identify it on a diagram. We've got reduced filling, which is from that second X to the third X. And then the rest is atrial contraction. Okay, so we consider this rapid, reduced, and atrial. And so during rapid and reduced filling, it's passive filling, okay, meaning the ventricle's not contracting. What happens is the valve between the atria and the ventricles opens, blood just drains into the ventricles. But at the end of that, the atria contracts to top off the ventricles so we can get as much blood into the ventricles before they contract. And so that's where we're going to end with this, this mini lecture, and we'll continue from this point with part 2.